and embedded system. And this lecture, the agendas are characteristics. I will explain you the characteristics of embedded system, quality attributes of an embedded system also. The learning objectives are you are learn the characteristics describing an embedded system. You learn the non-functional requirement that needed to be addressed in the design of an embedded system. You learn the important quality attributes of the embedded system that need to be addressed for operational mode, that is the online mode of the system. This includes response throughput, reliability, maintainability, and security, safety, etc. And you learn the non-operational modes, which are also called offline mode of the system. This include testability, debugability, evaluability, portability, and time to prototype and market, and per unit cost and revenue. You understand the product life cycle also. You will learn the whole product life cycle in these lectures. Introduction. The characteristics of embedded system are different from those of general purpose computer, and so are its quality metrics. There is big difference between embedded system and general purpose computer. Embedded systems are designed for a specific task. The washing machine, you only can wash the your clothes. It cannot use as a microwave. Whereas general purpose computer you can use in many ways. Okay. This chapter gives you a brief introduction on the characteristics of an embedded system and the attributes they are associated with its quality. And the characteristics of embedded systems, unlike general purpose computer system, embedded system possesses certain specific characteristics. Okay, and these characteristics are unique to each embedded system. Some of the important characteristics of embedded system are application and domain specific, and reactive and real time, operate in a harsh environment, and distributed, small size and weight, and power concerns. Okay. Application and domain specific. An embedded system is designed for a specific purpose only. It will not do any other task. Example, air conditioner embedded control unit, it cannot replace microwave oven. Example, a washing machine can only wash, it cannot cook. Because the embedded control unit of microwave oven and air conditioner are specifically designed to perform certain specific tasks. Certain embedded systems are specific to domain. Okay. For example, hearing aid is an application that belong to a domain of a domain of signal processing and telecom, with another control unit designed to serve another domain like consumer electronics. Reactive and real time. Certain embedded systems are designed to react to the event that occur in the nearby environment. Okay. That event also occur real time. Example, flight control system and anti-lock braking system are example of real time system. An air conditioner adjusts its mechanical part as soon as it gets a signal from sensors to increase or decrease the temperature when the user operates it using a remote control. An embedded system uses sensor to take input and has actuator to bring out the required functionality. An operation in harsh environment. Certain embedded systems are designed to operate in harsh environment. Okay, like dusty or in a high temperature zone, or an area subjected to vibration and shock, or very high temperature of the desert, or very low temperature of the mountain, or extreme rains. These embedded systems have to be capable of sustaining the environmental condition it is designed to operate. Distributed, the term distributed means the embedded system may be a part of large system. Okay, these components are independent of each other but have to work together for the large system to function properly. Examples are automatic vending machines, okay, automatic tellering machine. The automatic tellering machine contains a card reader, which is responsible for reading and validating the user's ATM card, transaction unit for performing transaction, a currency counter, okay, for dispatching currency to the authorized person, and a printer unit for printing the transaction details. This is a complete distributed system. This can be visualized. This is an independent embedded system, but they are working together to achieve a common goal. And fifth point is the small size and weight. The embedded system that is compact in size and has a light weight will be desirable or more popular than one that is bulky and heavy. Okay. Power concerns. It is desirable that the power utilization and heat dissipation of any embedded system is low. The more heat is dissipated, the additional unit like heat sink or cooling fan need to be added to the circuit. Okay, so it will become bulky. Nowadays, ultra low power components are available in the market. Okay. The more the power consumption, the lesser is the battery life. So, the quality attributes of embedded system. Okay, there are two types of quality attributes: operational quality attributes and non-operational quality attributes. First of all, quality attributes are the non-functional requirement that need to be documented properly in a system design. If the quality attributes are more concrete and measurable, it will give a positive impact on the system development process and the end product. As I had already tell you, the quality attributes are divided into operational and non-operational quality attributes. The operational quality attributes present the relevant quality attributes related to the embedded system when it is in the operational mode or online mode. The important quality attributes coming under this category are listed below. The first one is response, throughput, reliable, and maintainability, security, and safety. Response is a measure of the quickness of the system. It gives an idea about how fast your system is tracking the input variable. Okay, uh, it matters. Like in flight control application, should respond in a real-time manner, whereas an electronic toy, the, the response time requirement for electronic toy is not all critical. Any response delay play critical. Any response delay will create potential damages to the safety of flight as well as in the passenger. Okay. Throughput. Throughput deals with the efficiency of a system. It can be defined as rate of production or process of a defined process over a stated period of time. Okay, the rate can be expressed in terms of unit of product, batches produced, or any other meaningful measurement. For example, in case of card reader, like the one used in buses, the throughput means how much transaction the reader can perform in a minute or an hour or in a day. Throughput is generally measured in terms of benchmark. A benchmark is reference point by which something can be measured. Benchmarks can be set of performance criteria that a product is expected to meet or a standard product that can be used for comparing other products of the same product line. Reliability. Reliability is a measure of how much percentage you rely upon the proper functioning of the system. Okay, or what is the percentage susceptibility of the system to failure. Mean time between failure and mean time to repair are the terms used in defining system reliability. MTBF give the frequency of failure. in hours, weeks, and months. MTTR specify how long the system is allowed to be out of order following a failure. For an embedded system with critical application need, it should be out of order of minutes. Maintainability deals with the support and maintenance to the end user or client in case of technical issue and product failure on the routine system checkup. Okay. Security, confidentiality, integrity, and availability are the three major measures of information security. Confidentiality deal with the protection of data and application from unauthorized disclosure. Integrity deal with the protection of data and application from the unauthorized modification. Availability deals with the protection of data and application from unauthorized users. Certain embedded systems have to make sure they conform to the security measure. Safety deals with the possible damages that can happen to the operator, public, and the environment due to the breakdown of an embedded system or due to the emission of radioactive hazardous material from the embedded. And these are the non-operational attributes